Our language was originally intended to be a much smaller version of Java, but as we developed it, it became more and more like Python. So that's why it's called PyJar. PyJar is a dynamically typed language with non-local scopes for functions, but not loops, similar to Python. It's modeled as a procedural language and supports scripting. It has static scoping, and function arguments are passed by value. Functions are not first-class objects. Operations supported are loops, conditional expressions, I/O in the console, functions, recursion, and built-in stack. This project used several tools. The compiler is Java-based. The lexer and parser were built using Antler 4.5.3 within the Eclipse Antler plugin. The grammar is represented in a .g4 file, which is the Antler grammar file format. The intermediate code is generated through the parseTree Walker class by creating and listening a listener file. Creating and running a listener file. The runtime is Python-based, runs the intermediate code file generated by the compiler, prints output on the console. Programs. To understand how to compile and run PyJar programs, we're going to show you an example later, but here's a list. PyJar has three data types, a Boolean, an integer, and stacks are implemented as a built-in data structure, and that's it. There's no need for strings or anything else. Declarations and assignments. Since PyJar is dynamically typed, we don't need to declare a variable before using it. The syntax uses block structure that's similar to Java. However, there's no need to write semicolon at the end of each line, which is great because I always forget them. Also, there are no strict indentation rules that need to be followed because white space is ignored. Programs can be written as a script. The language also supports complex assignments, evaluates arithmetic and Boolean expressions. Here are just a few of the intermediate code operations. So read gets input from the user and pushes onto the stack. Store pops a value from the stack and stores it in a variable name. Here are a few examples of the intermediate code operations. Because PyJar has only three data types, the list of operators is fairly short. They're also not very exotic. So, as you might expect, the integer operations include multiply, divide, and modular addition, or modular division. And you can probably guess what the other ones are. But if not, they're listed here. Branching is handled by what you would expect, a typical if-else, else statement. However, if-else and else statements themselves are optional, just like in Java. Looping is handled by a while loop, which is a built-in mechanism. Functions. Some important features. Functions need to be defined before they are called. For functions, arguments and return statements are optional. Data types are not required in the argument list. Functions are preceded by the keyword func. So, to show what the language can do, here is an example.
So I'm just going to run through some code, an example program, and show you how to install it. So we just go to this GitHub repository and download a zip file. So here you can see there's the runnable jar for the compiler and the Python script for the interpreter. So what I'm going to do is I'm just going to run through a sample program that I've already created. This is the factorial program, and this is a recursive version of it. The parse tree looks something like this. So I'm just going to copy this and put it in a file. And I'm going to go to the command line. And you just say the name of the file that you need to run. So now you can see that there are two other files that are created in the folder. One just shows the parse tree as a string, and the other one is the intermediate file. It has the intermediate code. So what I'm going to do is I'm just going to run this intermediate code on Python on my interpreter. So it prompts you to enter the file name. So since this is a factorial program, I need to enter some sort of input. So suppose I want the factorial of 5, which is 120. So apart from this, there are a few other examples on the Git file, on the GitHub repository you can run. They're all in here. There is stuff for Fibonacci and some other programs. And that's about it, I guess. Thanks for watching.